Hello and welcome to Codeblaze and continuing on with the series Color Dash a project overview. Okay, in the last episode we went over Zenject and how Zenject has been implemented in Color Dash, and in this episode I'll be going over the platform system, how the platforms are randomly generated and placed to create the infinite scroller. So just to go over it, if I start the game, you can see these platforms are randomly placed at random transforms and they have random sizes and random colors. So I have a platform system which actually does that, and I'll be showing you that today. So the platform system starts with the platform entities, which is the mono behavior that each and every of these platform have. And there are two types of platform, the moving platform and the static platform. So these two gray bars are actually the static platforms, which restrict the player's movement in the y-axis, and the other platforms that are generated are the moving platforms. The reason I have this abstraction is because I want each and every type of platform to have a color index, and this color index property is then retrieved by the player on collision to actually operate the game rules, so increasing the speed and decreasing it, all that. But the platform system actually works on these moving platforms, and I'm using object pooling here, otherwise it would be really inefficient to instantiate new platforms every time and destroying them. So at any given time the pool contains 10 platforms, and then those are then again deactivated and activated at new positions with new transforms and colors. So to use object pooling, I'm using one of Zenject's features called memory pools, and there are many different types of memory pools in Zenject, but the one I'm using here is the mono memory pool, since I want to create a memory pool of mono behaviors. Okay, so you can override many methods from the mono memory pool, but the one needed here for my use case was this reinitialize method. So this reinitialize is called every time I request an object from the pool. So it really makes it easy for me to do operations. So the two operations that I need to do is the generation of the platform, that would be the size and shape, and the placement. So you will see that the platform system is actually split into two parts, the generation and the placement. And the reason for this split is, like, if in future I want to add some pickups or some coins, the way I can do is, like, I can have them also use the placement system. So that will, like, I need to define my placement rules and one position only, and will just make it easier. So that's why there are these two systems. And if I go to the actual platform system which manages this, you can see I have these two generation system, the placement system, and the actual memory pool as private members, and they are injected by Zenject here. Okay, this also follows a facade pattern that I went over in the last episode. So if I take a look at the DI and the systems, I have this platform system installer. So I'm using game object context because I don't want everything from my platform system to be available everywhere. So what I do is I bind two instances. So these are the settings objects. Setting objects are nothing but if I look at my systems and the platform system, I have these two settings objects through which I can tweak the parameters of the platform system, like the generation system settings and the placement system settings. So it just makes it easier for me to, like, in one place change everything what I want. So these settings objects are just plain old C# objects, classes. They don't have any methods, and I basically serialize them and then I bind them as single, because these settings objects will then be injected into our systems, and I bind that type also as single, and I then bind the memory pool. So with this thing, and here is where I define the size of the memory pool and which object's memory pool it is, and I can define other stuff also, like it comes from the platform prefab and where these objects will be initialized under which transform. So I have this platforms transformed under which these things are initialized. So that really makes it easier. So this platforms transform is where all the 10 objects will exist, and they will be activated and deactivated as and when required. Now we'll take a look at the granular level, the placement and the generation system. So if we take a look at the generation system here, you can see the serializable class. So this is basically the settings class, and this is injected here. Also with the game colors. And the game colors is nothing but a scriptable object that I have in my project where I have defined all the colors that are being used in the color dash. Currently it has only 4. So if I look into this objects folder, I have this game colors object which has 4 colors and a wall color. Wall color is basically this gray color, and I have a walls generation also, which are basically vertical platforms that are randomly generated. So I can add more colors here. So then more colorful platforms will be generated. So this way I can easily control or change these colors if I want, or add more colors, and they'll be propagated throughout the application. Okay, back to the platform system placement generation system. Sorry. So once these are injected, I have this generate platform method that is called in the reinitialization of the memory pool. So the moving platform C, it calls the generate platform and the place platform. And generate platform basically uses some random numbers to change the random range between the wall minimum and wall maximum, and that's how the scale or the size of the platform is decided. The same randomness is used to decide the colors. So I have this probability here, like I have 10% chance of generating a wall. Other than that, if the wall is not generated, I get a random color from the colors object, and this is pretty simple. And whenever this is generated, I call this update sprite color. Since we are using object pooling, the same thing is being generated, the same objects are being used. So this update sprite color basically changes the color in the sprite render, and that's it. And coming to the placement system, again we have the settings object which is injected, and I maintain this private last placement vector. So depending upon the last position where something was placed, I add some random values to it. So the next thing is always placed after that. So basically the generation rules are defined in these two systems, and according to them the whole system works. But the main and the major thing that is done is by the memory pools, all the activating and the deactivating of the game objects, reclaiming them. So everything is done by the memory pools, and you can see using Zenjix memory pool, I don't have to do anything. And the way I tell it when to reclaim it and when to add a new stuff is using this trigger. So these triggers are something that come from UniRX. So UniRX, you have a thing called triggers that basically for every Unity event like start, update and all, they have triggers. So you can subscribe to them. So this on trigger enter. So basically I have a garbage collector kind of thing on the player, which see this collector. If I go to the scene view, so this collector is a box collider which is far behind the scene, and whenever anything enters this collector, this subscribe method is called. So I basically check if it has the tag platform. Okay, so I call the despawn method in the object pool, and I need to give which object to despawn, and then I again call the spawn method, giving it the placement and generation system. So that's how everything is managed. The whole cycle is pretty easy to do using this Zenjix memory pooling. And to initialize them, I basically in the start I call this initialize method. This basically spawns that platform 10 times, and that's how the whole placement system or the platform system for Color Dash work. I hope you like this video. If you have any suggestions on how this could be improved, and if any other suggestions you have, please leave them down below. In the next video, I'll be going over how the main game rules are implemented, like how the speed is increased and decreased, and that's heavily done using UniRX only. That really makes it easier. Like you will see the amount of code that I had to write for all this stuff is pretty less, or you may argue it's more also, depending upon like the way you see it, but it is much more readable this way. I call spawn, despawn and everything. I don't need to manage the pooling and setting them active and all. So just subscribe and wait for the next upcoming videos, and soon I'll be hitting 100 subscribers, and I'll try to do something special for it. I wasn't able to do anything special for 50 subscribers, though I promised, but I had some unfortunate situations that I had to face with. But definitely for the 100 subscribers, I'll try my best to do something special. If you have any suggestions, or if you want some tutorials on some other topics regarding Unity or web development and Node.js, leave them down below in the comments, and do leave a rating. That helps me a lot. Thank you. Bye.